Gentlemen, welcome to my channel. Hoping that all of you are doing good. In part 7, we have seen types of forklift masks in detail. Today, we will be going through forklift carriages and forks. Most people think that the carriage and forks are the simplest parts, and so mostly they are overlooked. In fact, they are important in selection of suitable forklift. Let us see what is a forklift carriage. Well, a forklift carriage is made of flat metal plates that move along the mast, normally by chains. The forks are connected to carriage as per ISO classes. There are 5 carriage classes ranging from class 1 to class 5. It is essential to understand the class of forklift carriage because it can tell you the kind of forks that will work for your needs. These classes are according to capacity of the forklift against certain load center distance. For example, class 1 carriage can take load up to 110 at 400 millimeters load center. A class 2 carriage can take load between 1 to 2.5 ton at 500 millimeters load center. If you look at class 3 carriages can take load between 2.5 to 510 at 500 millimeters load centers. A class 4 carriage can take up to 810, and class 5 carriage can take load up to 1110 at 600 millimeters load center. You know, the load center is the distance between the front face of the forks and the center of gravity of the load being carried. How do you understand that your forklift is suitable to take certain load? Let us see the simplest way of understanding. We know that every forklift has a data plate attached to it as per the regulations. The data plate will tell us very crucial information about the truck, such as the mass height, rated capacity of the truck, load center, and such information. You may also see a chart indicating derating of the load at various load centers. These indications of capacities are against certain load centers and at certain lift height, as the load capacity vary at different lifting heights. The residual capacity of the truck decreases as the load center goes beyond the rated load center, and also whenever we try to lift the load upwards. Now let us approach our question technically. How can we calculate the residual capacity of the load that we need to handle? Suppose we have a 5-ton capacity forklift rated at 600 mm load center. It means that the forklift can carry 5 ton when the center of gravity of your load is 600 millimeters. Here we assume that we are handling a standard pallet of 1.2 by 1.2 meters. We know that our rated center of gravity is 600 millimeters for a 1.2 meter pallet size. Now let us assume that we have a different load, say 1.8 meters longer. Here we are trying to lift a longer load. It means that the length of the load is increased by 600 millimeters, and so we have a new center of gravity of 900 millimeters instead of 600 millimeters. Remember that our rated load center is 600 millimeters, but the new center of gravity is 300 millimeters beyond the rated load center. So, in order to calculate the residual capacity of the truck with this new load, we have a simple formula. That is, divide the rated load center by the new load center, and the result is multiplied by the rated load. So, in our case, we divide 600 millimeters by 900 millimeters, and we multiply by 510. That gives around 3.33 ton. It means that we can lift 3.3 ton in case of the longer load of 1.8 meters. So we can say that the residual capacity of the truck is 3.3 ton as we lift that particular load. I'm sure that all of you are familiar with load and moment. For example, we have 5 ton capacity at 600 millimeters distance, which means that we have a load moment of 5 ton multiplied by 600 millimeters. That gives something around 3010, exactly 3010 millimeters. So this load moment is your base reference in order to play with various load dimensions. It is important to keep your load moment always stable for safe loading practices. In order to keep your load moment stable, you have two parameters to play with. Number one, reduce the weight and take a longer load. Or number two, increase the weight and make the load center shorter. In other words, make the load center of gravity closer to the carriage. If you wanted to lift higher loads, but of course within the rated capacity of the truck. Always remember that if you increase the load moment beyond the stable limit, as I said before, we are increasing the risk of accidents. Your forklift driver must be aware of this safe loading exercise. By the way, if you find your carriage not suitable for your forks, there are a few possible ways. If you need to increase the carriage width, there are duplicate carriages that can be mounted on your existing carriage. This is very useful in case you need your forks to be spread wider, or in case you need to have more than 2 forks, to carry multiple pallets. You can also change your carriage class by adding adapter carriages, which can easily be fitted on your existing carriage. Instead of buying a new forklift for your new application, you can simply hang on the adapter. You can attach a class 2 carriage on a class 3 truck and carry out your job. I feel that most people in the industry are not aware of this. Now, let us see how to choose the right forks. As everyone thinks, the forks are the simplest parts, and so mostly they are overlooked. You know that the forks are the toughest parts made through forging process. However, it is important to ensure that you have the right forks and it is replaced at the right intervals. Normally, we can use a caliper to measure the outer and inner wear of the forks. You know, the caliper has two jaws to facilitate this. Usually, when there is a reduction of 10% in thickness, the forks are recommended to be replaced. The forks are available generally as either hook mounted or shaft mounted. The hook mounted types are mounted with hooks that slide on the carriage. The shaft mounted type are, rounded on top of the shank, and they move on the carriage, the carriage shaft. For forklifts of up to 7 ton capacity, hook-on types are generally used. For higher capacities, say beyond 7 ton, shaft-on types are recommended. It is important to ensure that you have forks with sufficient length, width, and thickness to avoid bending. At the same time, it is essential to have shorter forks to handle lighter loads in confined areas. This is to avoid damage to other goods by penetrating into it. As a general rule, the fork length has to be 2/3 the length of the load. The forks come with different taper shapes in order to suit the application. They could be half tapered, full tapered, tapered with bevel on bottom, same like a chisel, tapered with bevel on top, according to the applications. The fork tips also have different shapes, such as flat tip, as we see most commonly, and also round tip in order to suit different applications. Whatever be your application, please share with us, and we will be pleased to provide you with cost-effective solutions. I hope that you enjoyed this session, and God willing, see you soon with the next part. And please share with me your feedback on this video. And this is Residual Capacity signing off. Bye for now.